Welcome to Study Loop.
Here, a wire is lying along a x-axis from y equal to 0 to y is equal to 0.25, and current is carried by the wire in negative direction of the axis, so minus g direction. So that is current is 2.00 milliampere, and that equals to 2 into 10 to the power minus 3 ampere, and that is in g hat direction. So let me write that as minus g hat. All right, and this is in ampere. Now what else? It is given that there is a uniform magnetic field B equals to, okay, so the magnetic field is dependent upon is varying along y-axis. So it says it will be easier if I don't write 0, the value is the same. So Tesla per meter and y, it is dependent upon y. It is varying, the magnetic field is varying along y-axis, plus 0.4 Tesla per meter along y and j hat. Alright, so we are asked to calculate the magnetic force on the wire. F is equal to what? So F is equal to IDL. It is the cross product of IDL and B. Right, we consider that the direction of length and current is the same, so IDL is as a whole a vector quantity, current and the length, right? So if you multiply I hat and B, so here if you see here, this component J cross J will turn out to be 0, and we are only, so this, let me write this as a small force dF. Okay, so because we have considered a small length, we are considering force on a small length dl, so let me write this as df, not f. So let me get back again here. So the current here, if it is I cross B, then that will give me J cross J will be 0, so the only term left will be this cross this, right? So just do that. dF equals to, what is this here? Minus 2 into 10 to the power minus 3, right? And what is B? The constant in B is 0.3, right? And we are left with now Y, and dl is dl. Let me write this dl as dy. This will make it easier to integrate, right? So let us change this formula as dy because the length is along y-axis. All right, now the length goes from 0 to 0.25, right? So let us integrate this to find out the total force. F will be sum of all forces from length 0 to 0.25. all right, so this will give me 0 to 0.25. and what is df? Right, so except the constants, it is y dy, right? And constants will be minus 0.6. Well, I think the minus goes off here. You know why? Because j cross I is equal to what? Minus k. So I will have to write here, add here the term of direction, that is minus k hat, right? J cross I is minus k. So the minus goes off here, and j cross k will be, so j cross I will be only k. So only k will be left here, and the other terms will be 0.6 into 10 to the power minus 3 and k hat, right? So if you integrate this, this will give me y squared by 2. So 0.25 squared by 2, and the other term is 0, so we don't need to write that. 0.6 minus 3 in the direction of k hat. So if you calculate this, this comes out to be how much? 1.875 into 10 to the power minus 5 k hat. We are done. We have finally determined the force acting on the wire along its length from 0 to 0.25. And this ends the solution for this question. Thank you for watching.